Okay, let's get started. Good morning, everyone. Welcome back. So this is the second lecture of this semester. Today, we're going to overview of the textbook, the Chapter 1 Introduction. And this slide is made by Professor Daniel Ch.1 and taught by Isabel. So today's focus is about money. Okay? Because the title is Power System Economics, it's actually about money. Well, this is a gold coin. I have a lot to talk about gold, but I do not do that today. So what about money? First, we can think about minimizing cost. We have a power system, and then we have two different types of cost. The first one is investment cost, right? So we need to build power plant. We need to build transmission line. We need to build distribution network. That involves transmission cost. Okay, generators, line, transformers, and switching devices. And also we have operating cost, fuel, personnel, the labor cost, and the maintenance fee. So we want to minimize these two types of cost. So about operating cost, you may heard of this kind of terminology, OPEX. Operating expenditure. So this terminology is commonly used in many companies, general companies. Okay, and so that's about operating cost. And another concept is, in Korean, this is called CAPEX, or in English, CAPEX. This is a capital expenditure. So that is about this investment cost. Okay, so generally we have two types of cost. And of course, in power system economics, yeah, that is also true. But money is also about profit. So we want to maximize profit. And so we will assume competitive electricity market. The market is evolving from monopoly to fully competitive market. Or we can say we want to maximize utility or benefits from consumers' perspective. So this terminology, utility, we will use utility a lot in this class. But the terminology utility is different from the utilities company. Okay, so please don't be confused. We will use this terminology, utilities. This implies the electricity company. But here, this utility is simply Hyo-yong in Korean. Okay? So this utility company includes electricity, water, gas, and heat. Okay? And these days, internet is also called utility. Anyway, in economics, in microeconomics, the customers or consumers want to maximize utility or benefit. But we are dealing with power system, which is a physical system. Actually, power system is the largest engineering infrastructure on Earth. And we need to operate power system in a reliable way. So what does reliability mean? So we have a thunderstorm or lightning. Even in the case, we want to operate power system in a safe way. So we can think of operational reliability, which means the power system should withstand faults, failures, or forecasting errors, and other regular operational problems. So faults and failures are similar, so they are called 장애, power system. We have some failures or faults in power system. Something like this kind of distribution line can fall into the ground. It is cut and fall into the ground. For example, the tree falls down and hit the transmission line or distribution line, and then this line is cut, and then what happens is we have a pole. This is a distribution network. This is a pole. This is another pole, and we have a transmission line in distribution network. Typically, this is 22.9 kilovolt. And when this is cut and it hits the ground, what happens? Can you think of what happens when this distribution network line hits the ground? Well, suppose that this is cut, and then this is ground. The symbol of ground is like that, right? And what happens? This is 0. This is 22.9 kilovolt. This line has very little resistance. A lot of current can flow from here to there, right? And actually, in this distribution network, you see there is a transformer. How can I draw that? Yeah, this is a transformer. And when overcurrent flows over this transformer, then it will break down. Right? So, and this is called a short circuit, because 0 volt, very high voltage, and we have excessive current. So even in the case, we want to make sure that the rest part of the power system operates correctly. Of course, the household that is connected to this transformer, they will experience blackout. But we want to make sure that other house can have electricity service as usual. Okay, so that is about reliability. And also, we want to operate the power system with some margin, and that margin is called security margin. So the terminology of power system is sometimes different from the terminology in computer networks. And one of the example is security. So when we talk about security in computer networks, this is about virus. Or, what else? Wormware. How can I say that? Virus. Malware. Yes, malware. So those things are about security. But in power system, this security is not about the security in computer networks. Security just means we operate the power system in a reliable way. Okay, so different terminology. The same word for different meaning. Okay. So we want to operate power system in a secure way with a security margin. So if we have that kind of security margin, then we can say the power system is resilient. The English meaning of resilient is that it can withstand natural disasters. So resilient means something bad happens. So for a short duration of time, the power system may break down, but it will recover itself again. So it goes back to the normal case. Okay, there's the meaning of resilient. For a very short time, it can be bad, but it comes back to a normal state. Okay? So to make power system resilient, we need to design the system with some additional facilities. Okay? So we want to build a robust power system. But to make power system reliable and resilient incurs some cost. So that is called cost of reliability. And providing a security margin costs money because we need to install additional facilities. So one of the example is running additional generators. We need to have some operating reserve. This operating reserve means additional generation capacity to cover unexpected high electricity demand. So typically, you may remember that last time I told you, typical core-based power plant has 500 megawatt. But yeah, but normally they do not operate at its full capacity because they want to be ready for some unexpected demand. So normally 10% or 20% of the capacity is not used, and that is reserved for future uses. Okay, so in that sense, you can say generating units have some operating reserves. It depending on scenarios and countries, can be 5% or 10% or something like that. And yeah, so what I'm saying is to have security margin, the operators limit production of some generating units to avoid problems in case of a sudden outage or a sudden load increase. But build additional generators and transmission lines to improve resilience incurs additional cost. Okay, so that is the cost of reliability. But also we have value of reliability. If the power system is reliable, then that means suppose that you are an owner of semiconductor factory. It makes chips, memories, etc., like Samsung semiconductors. But if blackout happens, there is a loss of revenue, a loss of comfort in the case of department store when the air conditioner is not working. Everybody is very hot, so they complain. Anyway, so people wanted to measure the loss of revenue or loss of comfort in a quantified way. So how can we measure the loss of comfort or loss of revenue? One of those ways is to measure using survey. The reason why we are using survey is because it's very hard to quantify the cost explicitly. So just ask the operator of each facility how much loss of revenue are you expecting if blackout happens. Okay, so they have some knowledge about that. So estimate the cost of the latest outage, or so we can estimate the loss of revenue using survey, and also that can be measured in another way. That is this one: willingness to pay additionally to avoid outage. So if outage happens, I would expect this amount of revenue. Then in other words, how much do you want to pay more to make the power system reliable? Okay, so that includes also cost, but hopefully there is no breakdown or blackout in the system. So the customers are willing to pay additionally to avoid outage or blackout, and that is called VOLL. So this terminology is commonly used a lot, value of lost load. So from this phrase, you can see that, okay, blackout happens, outage happens, then I cannot get served. So there can be some megawatt hour, tens or hundreds of megawatt hour, and then that value is this much. Okay, that can be estimated from this survey. So this value of loss load, or VOLL, is estimated ranging from a few thousand to a few tens of thousands per megawatt hour. And this is a lot higher than the electricity price. So typically, in Korea, what is the price of energy per kilowatt hour, roughly speaking? What is the electricity price in Korea, roughly speaking? Number 1, number 2, number 3, number 4, number 5, number 6, and more. Which one?
3.
3. Any other idea?
4.
4. Any other idea? Any other ideas? Well, yeah, this is the typical order. Kilowatt hour is roughly 101. And this is similar to $100 per megawatt hour, because kilo to mega 1,000, 1 to dollar roughly 1,000. Okay, so please remember this number. In United States, they say, or in the US, kilowatt hours divided by 1,000, that is 10 cents. 10 cents is 101. But this VOLL is estimated much higher than that. So 100, this is 2,000, 20,000. Okay, so up to 100 times higher than the average cost of energy. Why is that? The reason is because, again, you are an owner of some semiconductor manufacturing company, and if blackout happens, all the facility stop, right? And then you cannot make the semiconductor chips. Okay? And also it has another startup cost of those facilities. And actually the cleaning room, semiconductor manufacturing facility, that is very sensitive, right? So they need to calibrate all the devices again, something like that. So it incurs a lot of cost. So that's why we have a notion of value of reliability. To avoid outage, blackout, how much do you want to pay additionally? So we have a cost and we have a profit. We want to minimize the cost, but we want to maximize the profit. And we need to balance the greed and the fear. We want to maximize the profit, but also we want to avoid outage. We want to operate the system in a reliable way, but that incurs additional cost. Okay, so we need to balance these two things. Actually, similar concepts, greed and fear. This is used also in stock market. You know that. So I'm not encouraging you to do that. No, this is just a common sense. 공포와 탐욕 지수, something like that. The kind of concept exists in the stock market. So, we want to maximize the profit. We want to minimize the operation cost, but also make the system run in a reliable way. So this is a mathematical optimization problem. Cost minimization or profit maximization is a typical optimization problem. And about this reliability, this should be considered in a constraint. in many constraints. So the voltage should remain in some range, and the maximum power flow should within some range, blah, blah, blah. And, but the explicit costing of reliability, the measuring of reliability in dollar is not easy, so this is still a controversial issue. And these days we have one more factor, that is environmental impact. And you may know that climate change, climate crisis is severe and getting worse and worse. So we need to consider the environment. And from two factors, we have three factors to balance. Okay, we need to reduce the common carbon emission. Okay, so that is called three-way balancing. And when we consider the environmental effect, it becomes more complex optimization problems. And because of we need to reduce the fossil fuel-based generation, we have a lot of renewable generations, and the amount of generation changes over time, so it is not easy to predict. So that's why you study AI to forecast. And so it becomes more complex optimization problem under uncertainty, right? So decision making under uncertainty will be getting more and more important. So some environmental effects can be monetized. Monetized means it can be estimated in dollars. Okay? So for example, operating cost of renewable generation is essentially zero. Please focus on this part, operating cost. Renewable generation, once you install the photovoltaic panel or wind turbine, the operating cost, this one is zero. Typically we assume the operating cost is zero, but actually it's not zero, because in the case of PV, no, the solar panel will be covered by dust. So we need to clean that, right? And when the solar panel is covered by dust, the generation efficiency falls down tens of %. So that kind of maintenance incurs additional cost. And another types of environmental cost is carbon tax or carbon trading to reflect the effect of carbon dioxide emission. So you may heard carbon tax or 탄소세 in newspaper. So what it says is, in the manufacturing process, if carbon dioxide is emitted, then the company need to pay some money. Okay? So that is called carbon tax. Then what is carbon trading? In Korean, that is called 탄소 배출권. So every company can have their own rights to emit some amount of carbon dioxide. But if they over that, they need to pay some penalty. But if they are below the threshold, then they allow this amount to be emitted by some other company and then get some money. So I can trade my carbon emission right to others. Okay, so that is called carbon trading. Well, recently you may heard this kind of terminology, 탄소 국경세. Have you heard of that before? Okay, so we have many countries. Okay, we have many countries, and so export and import happens. But when a product is imported or exported, then the country can inspect whether this product is made in a environmental friendly way or not. So if not, they can impose additional tax for that. Okay, so that is called 탄소국경세. I don't know the English name for that, but you can check it. Okay. So this environmental effect is important and will be getting more important. Okay. But some other environmental effects cannot be monetized. For example, the effect of hydro generation on salmon. what does that imply? You like salmon, right? You like salmon. Yeah. This is a mountain. This is a sea. And we have some creek. And we have a river. And then, you know what salmon do, right? So they are born here and then go to the sea and come back again to lay eggs. But if a hydro power plant is built in this area, then that will destroy the ecosystem of salmon. Okay? But those things cannot be monetized easily. Yeah. So anyway, so those things can be modeled using additional operating constraints. Any questions? So far, so good. Okay. So in power system, we have government energy policy, and because the power system is involved with physical system, it is not purely considered as economic way. So not pure economics. And but anyway, if we have a short-term view means we only observe a short period of time. The markets and companies can take a short-term view, and then we can apply microeconomics. And actually, I will talk about this monopoly shortly. And in this case, we need to have the regulation from the government. And from long-term or strategic consideration, what is this? This is the government's, okay, let me think about it. This is about government energy policy. So from a short-term point of view, they want to make the market efficient. That means they want to make the market fully competitive in the long run. But we will start from this point, monopoly. And another consideration is long-term or strategic consideration is that the government wants to reduce the dependence on import. So yeah, especially in Korea, we do not have oil production. So Korea is relying on energy imports a lot. But energy security is also very important these days. You know that? Russia and Ukraine, they have a war, and the natural gas is an energy source, but it can be considered some kind of weapon. And it can threat the security of a country, like European countries, because Germany, France, those European countries are supplied from Russia about natural gas. Okay, so Russia can use their natural gas as a weapon. So the government wants to reduce their dependency on energy import, and Korea is not the exception. Anyway, so the government wants to introduce competitive electricity market in the long run, but it will take time. and we don't know how much time to take to fully make the market competitive. So that's why we are studying this field. Yeah, short circuit. Yeah, that's the alarm about a short circuit. Choice of primary energy sources is also important. So, Korea, still the main energy source is from coal power plant. It is decreasing, but still the coal power plant is the highest. But other countries like Germany, Germany is one of the leading countries in renewable generation. So promotion of wind and photovoltaic in Germany. By contrast, France, 70% of generation is from nuclear power plant. Okay, then you may think, hey, France, they have 70% of generation from nuclear power plant. Then why don't we do that? Nuclear energy is clean and cheap. But professor, you said that 30%, we only generate 30% of energy from nuclear power plant. They are 70%. What's the difference? You understand my question?
It depends on politicians.
Yeah, it depends on politicians, but my question is about technical side. From technical point of view, why we cannot increase the portion of renewable generation up to that of France?
We are isolated.
Yeah, we are isolated. European countries are all connected with each other. Okay, so when they have excessive power, they can be exported to other countries. When they have energy shortage, then they can import power from other countries. So it is a lot easier to balance generation and load equal all the time in European countries or in the United States because the system is so big. By contrast, in Korea, we are in the peninsula. We are isolated. And in terms of power system, that is more severe because we are connected with North Korea, but we are connected to North Korea. But from power system perspective, we are an island. Okay? So to avoid that kind of situation, there is a concept of East Asia supergrid, or in Korean that is called well, I first saw that terminology 9 years ago, in 2014. And actually, this woman, she graduated Sogang University in 2017 as a master's student, and she applied for my lab. She said, I wanted to pioneer to make East Asia supergrid. Yeah, so that means, that implied she knows many backgrounds in this field, and at the time I wanted to expand my research field into power system, so Bora was the right person to do that with me. So from that time, the research field of NICE lab was expanded to power system and power system economics and renewable energy, blah, blah, blah. So she was the pioneer of power system at NICE lab. Anyway, where am I? Yeah, nuclear power in France. And yeah, energy conservation in the Pacific Northwest. This is about United States. Okay. Any questions so far? So far, so good. Yeah. Next topic is organization of the electricity supply industry. So roughly speaking, we have generators, transmission line, and distribution line, and in between we have a substation where the voltage is transformed from high voltage to low voltage, and then we have a residential side, or the customer. So, yeah, generation, transmission, distribution, retail, and customer. Initially, we can think of monopoly structure, and this is the traditional electric utility model. And Korea was not the exception. So before 2001 or 2002, something like that, still the Korea had this kind of a vertical structure. We had the monopoly structure. So only supply of electricity, only one supply of electricity in a given region or service territory. So customer does not have a choice of supplier. You don't have a choice of supplier still, right? So we are solved by KEPCO. KEPCO is still the monopoly company in terms of retail, distribution, and transmission. Then what about generation? Well, around 2001 to check the exact year on your own. This generation part was splitted as a subsidiary company of KEPCO. So those are 동서발전, 남동발전, 서부발전, blah blah. So we have 6 power generation subsidiary companies. Okay, that is kind of the starting point of migration from monopoly to fully competitive market. Just a first step. I think it will take a very long time. So this part was split. But let's just focus on the pros and cons, the advantages and disadvantages of monopoly structure. So this is called a vertically integrated model. So a single organization performs all the technical and business functions. This technical function means build the system and manage the system, run the system in a reliable way. This business function means selling and buying. This is about money. This is about the operation. Okay. And so this is a very abstract word. We have commonly 3 types of customers. You are one type of customers, residential customers. Another type is commercial. The other type is industrial. So commercial customer is something like building or department or a school. Okay? Non-residential customers. And industrial customers are factories. Okay? So please check. Yeah, because we are talking about customers, 3 different types of customers have their own power consumption, and I'm curious about the ratio of these 3. Check it. Okay. C, I, and commercial, industrial, and residential. Check it on your own. So why do we need this vertical integration first? The reason is because it is considered more efficient. What a surprise. What a surprise. In microeconomics, we assume fully competitive market to be efficient, right? But here I'm saying, hey, this monopoly structure, the vertically integrated structure, is considered more efficient. then why do we need to transform from monopoly structure to fully competitive market? It's kind of ironic. What's happening now? Any idea? So you know what I'm saying? You see what I'm saying, right? 지금? What was my question? What was my question?
그 완전 경쟁 시장은 뭐 이상점 다 있겠어. 근데 여기서 모노폴리 가정하고
Yeah, exactly. So I said fully competitive market is efficient, and that is the basic assumption of microeconomics, and that makes the analysis very easy. But here I'm saying, hey, a vertically integrated structure is more efficient at an early stage. At an early stage. So let's see why that happened. Before talking about the advantage of vertically integrated model, let's talk about the drawbacks first. This monopoly is not good because it lacks of transparency. Okay, can you imagine that? Poor internal communication in very large organizations. When you later go to a company, a big company, when there are a lot of employees, when there are a lot of departments, you will see the internal communication is not quite easy. They don't want to share their information with other departments because there is an internal competition. They need to be promoted, right? So, okay, so I will say the advantage of monopoly model shortly, but let's talk about it's not good. So why? No, because we have these issues. So we can some slight variations. For example, possible variance is distribution plus so distribution and retail and generation plus transmission. We can split this into two parts. So distribution plus retail means, okay, generation and transmission is one side, distribution and retail is the other side. So they manage the distribution network. From a technical point of view, they manage the distribution network facility. And about this retail, what does the meaning of retail? The meaning of retail is selling and buying of the electricity. So the customer need to contact this retailer to complain about excessively high electricity price or cost, blah, blah, blah. They don't need to directly contact the technicians of the distribution network. And this generation and transmission can be still considered together. And one of the example is Bonneville Power Administration. And what is that? What is that? So this is the name of some location in the United States, in Oregon. So in Oregon, Bonneville, this is the name of a city. They have this kind of structure. So then let's talk about at an early stage why monopoly is efficient. The reason is because building a power system is very expensive. Think about a developing country. Some developing country. Actually, Korea was a developing country 40, 50 years ago. Okay? At the time, what did we need to do? We need to construct highway from Seoul to Busan first. Right? We need to construct the power system network. That requires huge capital expenditure. The competitive market means we have many players, but that implies there is a redundancy, right? So when you think about the mobile communication networks, we have SKT, KT, LG Plus. Previously, there was another company, I forgot. Okay. In 1998, when I first subscribed PCS service from this number, 016, this was offered by KTF, Korea Telecom Freedom. This is, yeah, and well, yeah, in 1998, in 1998, I think we have one more company, but I don't remember. This is SK Telecom. I think this was 신세계 통신. I'm not sure. Please check this on your own. I think this was this was LG blah blah blah. I'm not sure, but you know, we have this and that and that. We have 5 wireless mobile operators. That means they need to have their own base stations. They need to invest independently, and that implies 5 times of investment, right? Yeah, we have another story, but so this is not the case of monopoly. Actually, before that, the wireless network was also a monopoly, the KT. And then KTF emerged, and then SK Telecom was splitted from Korea Telecom, and then competition was introduced. But for power system or the highway system, still we are maintaining this monopoly structure, except the generation part. The reason is because building a power system is very expensive. So from government point of view, or from societal point of view, building a highway or this transmission network by a single entity is more efficient than redundantly construct 2 different networks. Okay. So building competing transmission and distribution networks does not make sense because it incurs the cost twice, 3 times, etc. So this kind of situation where the monopoly is optimal or monopoly is efficient is called natural monopoly. This is a good terminology. This means the case when the monopoly is efficient. Okay? And that is the case at an early stage. We need to install the infrastructure of the society. So you may heard this kind of terminology before, SoC, not system on chip, but what is that? In Korea, this is called 사회 간접. Okay? Are you new to that terminology? SoC, 사회 간접적. What are you talking about? Check it. Okay? So in terms of the things, natural monopoly is typically happening. So until recently, having several companies share a power system was too complicated. Yeah, what it says is, hey, rather than having a monopoly company and let them construct a highway on their own, what about introducing 2 competing companies and build highway or power system and make them share their networks together so that operate the networks more efficiently? That implies, again, from wireless system SKT, KT, LG Plus, they have their own base stations. But if they can share the base station with others, from customer's point of view, we have 3 times more connection opportunity than before, right? Because currently I'm using KT, so I'm connected the base station of KT. But if they can share their base stations, then I can access LGU Plus or SKT, which is closer to me, right? So if they can share the network, we can make the system more efficient. That was the problem. Yeah, the problem is they do not want to do that. Okay, they don't want to do that. So 10 years ago, a lot of researchers like me studied the network sharing problem. So you can give access to your own base station to other players, and when their traffic goes through me, then charge them some amount of money. Right? But anyway, by this kind of sharing the system, we can make the whole system better. Yeah, ideally that is true, but they don't want to do that. There are some reasons. Maybe the first reason is the privacy. The second reason is they cannot trust others perfectly. Right? Third reasons, it makes the system complicated. Okay? So the operators in each company don't want to do that. Okay? Of course, if it works well, then it will improve the efficiency, but it has another side effects. So, yeah, in power system, yeah, that is also true. At an early stage, we have this monopoly, and this monopoly can have 2 types: the private monopoly and public monopoly. Public monopoly means you usually think monopoly is public. That means government or municipal or utility district, or the government owns the facility. That's the public monopoly. But private monopoly is also possible. That means investor-owned utility can exist. So this is the example. Example 1, Puget Sound Energy. This is an example of investor-owned utility. So this is a private monopoly case. So when you look at this, where is it? Can you guess where is it? The hint is this is in the United States. Another hint is we have some districts, Pacific. So yeah, probably this is California or the state over the California. What is the state? California, Nevada. What? What is here? What is the state of California?
San Francisco.
San Francisco is a city in California, not state. So what is the name of states that is above the California? Is there anyone who visited the United States before? Okay, then at the time you didn't look at the map of the United States carefully. So this is in Washington. Okay, so that, am I correct? Let's check. Puget Sound Energy. Let's Google. Yes. Maps.google.com. Puget Sound Energy. So yeah, this is California. This is Nevada, and this is Oregon, and then we have Washington. So Puget Sound Energy is here. This is close to Portland in Oregon. Actually, I was in Oregon 15 years ago when I was an intern at Intel for 7 months. Anyway, so this Puget Sound Energy is an example of investor-owned utility, and this is a private monopoly. The interesting part is this yellow means electric service, but they also provide another types of utility, natural gas, green. Okay, so an example of sector coupling, natural gas is provided from the company. It's a kind of sector coupling. And this orange is combined electric and natural gas service. This orange one. Okay. Next. An only example of sector coupling. What is sector coupling? If you are curious about that, please ask Minji. Okay. He already published one paper in that field. The second example is the Seattle City Light. Where is Seattle? You don't know? Where is Seattle? Come on. Seattle is in Washington, okay? So, okay, from Seattle, that's Seattle. So Seattle is here. The Puget Sound Energy is around here. So I was here, Hillsboro. There is a big Intel the semiconductor manufacturing facility there. And from Portland to Seattle, this is very close. I guess maybe less than 1 hour. So let's check that. Portland to Seattle. So don't trust me too much. You need to check it on your own. It takes around 3 hours. Yeah, sorry. Okay, then we say Vancouver. I was there too. I spent my sabbatical at Vancouver. And from Vancouver to Seattle, it takes 3 hours maybe. Yeah, roughly you see that, this distance, that distance is similar. Anyway, so in Seattle, we have Seattle City Light that is owned by the city of Seattle. So this is not private. The city owns that utility. So this is an example of public utility, public monopoly. The third example is about BC Hydro. This is owned by the province of British Columbia. In the United States, how many states do we have? 51. Then in Canada, how many province, not state, how many province we have? 5, 6, 7? Check it. And BC is one of that, and this is on the west side. So I was somewhere here. Where is Vancouver? Victoria. I don't know. Anyway, so this is a public monopoly. So BC Hydro is a utility company in BC area, and our main power source is hydro. So let's look at the types of utilities in the United States. Actually, well, the total number of utilities, can you sum up this? then it is more than, I guess, 3,000. Okay? In the United States, we have a lot of utilities, around 3,000. Investor-owned companies, private, 265. Municipal system, 1,800. Municipal is, you know the meaning of municipal? You don't know. Just some small area, small district, town, something like that. And public, power district, state, county. Yeah, municipal, what is the concept of county? You don't know. County is bigger than city, typically. In the case of LA, we have LA city, but we have LA County. Okay? LA County is much bigger than LA City. Rural electric co-ops, U.S. government, blah, blah, blah. So, in the United States, there are many number of utilities and many different types of utilities. That means, in this figure, in the United States, there are a lot of retailers and distribution networks, operators. Then let's talk about regulation. Because power system economics is related with power system, the physical system, we need to operate it in a reliable way, in a secure way. So the government needs to intervene in the operation of power system. That is called regulation. The reason why we need to regulate the power system is because a private monopoly company could abuse its position. That's the most downside of monopoly, right? They can exercise their power and they can, how can I say? They can be greedy to maximize their profit at the sacrifice of customers' comfort and expenditure. So that must be regulated by the government. Yeah. So in the case of private monopoly, it requires the regulation from the government. In the case of government-owned utility, do we need regulation? Actually, we do not have that kind of regulation. We don't have the need for outside regulation. The reason is because government-owned. Government is an entity for regulation. So it is kind of weird. We have a government, but we have another regulatory body to inspect that. So rather than doing that, if we are not satisfied with their service, we can vote. We can replace the government, right? So elect new representatives if we are not satisfied. Anyway, so this regulation and regulatory compact is important, and there is an agreement between an investor-owned utility that's private. The abbreviation is IOU and government. So IOU, the private-owned utility, receives the right to be the monopoly supplier over a certain territory, and because they are monopoly companies, they need to accept the rates, the price, and this is determined from the regulatory body, the government. This is still the case in Korea. Okay, so you can watch the news. The government allows or disallows the increase of electricity price. These days, the KEPCO is experiencing difficulties because of the increase of the price of natural gas because of the Russia and Ukraine war. But they cannot increase their electricity price without permission of the government. And the reason is because they are a monopoly company. So, yeah, rates means what it can charge consumers. That will be determined by a regulator. So, the example is Washington Utilities and Transportation Commissions. Rate of return regulation. What it says is the regulator sets the rate, the price, so that the IU can, the monopoly company first build the system that requires capital expenditure, right? So they need to get paid, they need to recover the cost. So recover is operating cost and investment cost. So to recover that, they need to set the price properly, but not too high. Okay. So the regulatory body need to decide what is a good rate to recover this cost, but not to set the price high. Let's see. We have many slides to go. Okay. Okay, so I will explain the rate of return in the next slide. Oh, here. So, monopoly utility is a low risk investment. The reason is because they do not have much risk. The reason is because there is no competition. And anyway, the regulatory body allows to set the price to recover this cost. Okay? So they don't need to worry too much about their revenue. Okay? Because nobody wants the monopoly company bankrupt. If that happens, we all experience very difficult situations. And then the issue is how can we determine the rate of return properly. So this rate of return can therefore be low compared to other investments. What is it? So let's see this. Suppose that now you are an investor. Okay, you invest some money. Let's say that investment is the amount of the money is A. And okay, invest. And this is timeline. This is the time at which you invest. You invest this amount of money at this moment. And then 1 year, 2 year, 3 year, time goes on. And after this invest, you can get some cash. You have some cash flow, like a B1, let's say B2, B3, B10. And nth year later. Okay. So at least the sum of future cash flow and the discounted value of that using some interest rate should be, so the total sum of cash flow in the future should be at least this much. Other than that, the monopoly company cannot recover their own investment cost, right? So B1, let's say R is the interest rate. Okay, so, and this is the cash flow at the first year, cash flow at the second year, etc. In the second year, this should be discounted like that, right? start year, dot, dot, dot. So any year, you can expect this amount of cash flow, and they should be discounted by like that. R is the interest rate. By the way, this rate is kind of ratio, but here this rate is price. Okay. Sorry. This rate is the interest rate. So how can we determine I'm confused. This rate is not interest rate. This should be rate of return. And this rate of return is commonly used in investment and in economics and or in the company. And the R that satisfies this equation is called rate of return. And this R why is it price? Check it. Check it on your own. I will ask you next time. Okay, so the point here is that the regulatory body does not allow this rate of return too high, because then the customers need to pay too much. But it cannot be too low, because in the case the monopoly company cannot recover their investment cost. But typically in the monopoly case, this rate of return is usually lower than other investment case, because the government does not allow too much excessive rating. Okay. Let me stop here, and next Monday we will continue on chapter 1. By the way, even if we didn't finish chapter 1 yet, but it's good to read in advance on your own. Just 7, 8 pages. Okay? Thank you.